Hello, Mr. Worth. Today I'm going to be doing the magnetism reassessment. So, these are two concepts that I got wrong on the test, and they were very big and they're an important part. So, this one is explaining the right-hand rule for determining the direction of the magnetic field around a current carrying wire. So, I drew this just to make it more clear. So what you have to do is you just put your right hand around this rod, and as you see, where your thumb is pointing, which is upwards here, the current is going upwards, and then the magnetic field is following your finger, so it's going around the rod. So just to show you how to do it, says you make your hand into a fist as shown, and then the thumb then points into the direction of the current, while the fingers will curl in the direction of the magnetic field, as shown. And then I also got this one wrong, which is also a very big part of the test. Explain the right hand rule for determining the location of the north pole of the magnetic field of a solenoid. So you have to draw this diagram, and it has this one guy, it shows a right hand and is holding a solenoid. So you grip the solenoid with your right hand and line up your thumb on one side and curl your fingers. This is where the current is flowing and is the opposite of electron flow. And the thumb is pointing towards the north pole. So as you see, the thumb is pointing towards the north pole and the fingers are pointing upwards, which is how the conventional current on the right side is going upwards, and then it's leaving and it's going down from the north pole. Okay, so this is an example of where you would use this in a question. So it says, which diagram below best represents the magnetic field around a straight wire? Which electrons are flowing from left to right? So you can automatically get rid of two of them, which would be this one right here, and then this one right here. This would be because this one only has circles. Circles represent that the electric field is coming up, while the X's represent the fields going downwards. And you can remember this by imagine an arrow going away from you that has a crosshairs, which is makes the shape of an X, and then the circle is like the point, which is coming towards you. So this one and this one are automatically gone, and that leaves you with the first one and the third one. And then you gotta remember that so you gotta do the right hand rule as shown above, and then you realize that it's the first one. Use the right hand rule and you get the first one as the answer. Okay, now I'm going to be showing these magnetism examples of where they have magnet and it has the flow. So what you want to remember is that it always goes from north to south. And so on a single bar magnet, the flow would go from the north to the other side to south like that. Now if there were two magnets with like poles like this, the two poles would repel each other because the opposites attract. So then it would be like this. They wouldn't combined. And then this is two magnets with opposite poles next to each other, so the charge would again go to the south and opposites attract, and then the north here would go all the way to the south on the other side if there wasn't any closer ones. So this is a horseshoe magnet. So the side is north and the side is south, so it just goes directly to the south side. That's how a horseshoe magnet works. Okay, and this is two important things to know. Magnetic fields are strongest when lines are closer, and magnetic fields are created by moving electrons. Okay, so this is a question. An electromagnet would have the greatest strength if the wire was wrapped around a core of A, wood, B, iron, C, aluminum, or D, copper. So you already know it's not going to be A just because you want to know it's going to be a metal because metals conduct. And then you want to choose iron because you just have to know that iron acts to concentrate electromagnetic force. And then here, okay, so at which point is the magnitude of flux density due to the magnet the greatest? And you look at this and you usually know it's not going to be A or C just because it has to be between. are close to the charges, and then D is on the wrong side. So then you realize it's A because A is in the center, and the answer is B because that's where the lines would be the densest, as it's midway between the two magnets. Okay, and then on this question, it has this diagram, and it's going to ask you where is the charge the greatest, or the magnetism the greatest, and it's going to be C because, once again, when the lines are closer, that's when they're the strongest.